Yeti and I have been working on this project, right, Yeti? Yeti's very good at math, and we were doing something that was discovered by John Napier, you know, the Scottish mathematician, the inventor or discoverer of logarithms. And this is one thing called his bones or his rods, Napier's bones or Napier's rods, a template that I made. Nothing more than a fancy multiplication table, really. So you see 3 times 4, 12 is just written in a certain way, diagonally that way. There's a logic to it. So this was a quick multiplication technique, that method or tool. It was physically bones or rods. You can see them in the museums, like the old museums, the National Museum of Scotland. You could see them in other museums. This is a quick example of how it works. I think students are going to love this. So, you know, let's say we want to multiply 634 times 8. And if you were in the 1500s, 1600s, the way you would do it is you would take the 6, the 3, the 4. So you take these bones, you have a stack of bones. Here's 6. Yeti, did I do something wrong? 634, where is the 6? We have so many of them, Yeti. Yeti helped me cut these. He is amazing. Yeti, math genius. I think the students are really gonna love this. So you take 634, you line them up. Yeti's very good at lining them up. So this is 634. Does everybody see that? This is 634. And you line it up this way. And you're multiplying it by 8, let's say. So we are looking right here. Oh, here, let me cover it up. Let me move it up. That's Yeti drinking water. I'm about to take him for a walk. So remember, we're doing 634 times 8. So we hold up and we see what we have now. Students are going to do it much better, much faster. But let me just, so 638, yeah, this is very bad video editing. No video editing, this is on the fly. 638, line it up. I'm sorry, what did we say? 634 times 8. Yeti, thank you for the correction. And you look at that and you just do some simple addition. Let me just make sure you see it. So now you do simple addition. I'm not in my permanent place. So the first number, you get the 2. You just write that 2. And then you do 3 plus 4. What is that? 3 plus 4. Yeti, what is 3 plus 4? 7. 2 plus 8, that is 0. We carry the 1 on top of the 5. 4, it becomes 5. Need a comma, and that should be the answer. Oh my goodness, wasn't even in the frame. This is horrible. Horrible. What kind of quality video is this? But there you go. The 2 comes down to the singles digit. The 3 and the 4 add up. It gives us the 7. The 2 and the 8, 0. Carry the 1, 4, right there. So all these are, that's just a quick calculation. If we wanted to do a 2-digit number, let's say we wanted to do, let's say 27 times, just making it up, 27 times 34. So mathematicians used to know that what you do is you really, the distributive property, you multiply it first by 27, you know, you do 27, you do 27 times 30, and then you do 27 times 4, and you add them up. And you could do that here as well, exactly the same way, but all this is just based on Napier's method of multiplication. And in the 1500s, 1600s, this was a big deal. This was like a huge calculator technique. And Yeti had fun with it. I think students are going to have fun with it, Yeti. Never mind my lousy video. I think students are going to have fun with this, especially that we did it. This is a prototype. I think students are going to love it. And you see, it's nothing more than just a fancy multiplication table. Okay, that's it.